We will cover a few different things in this video. The first thing we'll talk about is rate of change, also known as slope. Anytime you're asked for the rate of change, you are being asked for the slope. It is one and the same. So let me do one example for you. Here, I have a line. I am asked for the rate of change of that line, which means what is the slope? There are three ways to find the rate of change or slope. One way, and the way we'll use most often when we get into graphing, is rise over run. Slope or rate of change is rise over run. You rise up and down, you run left and right. Up and to the right are positive values, and down and to the left are negative values. I can pick any place where this goes right through the grid, which is here, 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 and here. All of those are places that line goes right through the grid, and I can use any of those points. I'm going to use this point and this point because they're both in quadrant one, quadrants 1, 2, 3, 4, x-axis, y-axis, origin. Since they're both in quadrant one, I know they're both positive numbers, which makes them easier to deal with. So I'll use this point, which is 3, 3, and this point, which is 2, 1. I rise 1, 2, I run 1. Rise 2, run 1. Your slope is 2. If you had have counted between the dots, you rise 1, 2, 3, 4, run 1, 2, 4 over 2 still simplifies to 2. You count between any of the places where it goes right through the grid, you'll get the same answer too. If I use a formula and I use those same 2 points, this was 3, 2, this is 2, 1. So the difference in my y's is 2 and 1. The difference in my x's is 3 and 2. 2 minus 1 is 1. Let's see. 1, 2, 3, 3. Mess that up. 3, 3 is right here. So the difference in my y's is 3 minus 1, and the difference in my x's is 3 minus 2. So my slope is still 2. If I had accounted right here, -3 minus 1 is -4, 0 minus 2 is -2, and -4 divided by -2 still simplifies to 2. And if I use a table, every single place where this goes right through the grid, right, let's see, -1, -5, 0, -3, 1, -1, 2, 1, 3, 3, and I didn't include it, but 1, 2, 3, 4, 1, 2, 3, 4, 5. 4, 5 are all places where this line goes right through the grid. I can take the difference in any of these. I could pick right here where my intercept is. I found the 0, which finds my intercept. I like positive numbers, so I'll just choose these 2 points. Doesn't matter, the difference in my y's over the difference in my x's equals 2. So whether you use a table, or whether you use the formula, difference in y's over difference in the x's, or whether you count rise over run, which you really need to be able to do, rise 2, run 1, rise 2, run 1, rise 2, run 1, you're going to get the same answer. The point of this is to let you know that rate of change and slope are one and the same. Rate of change equals slope. The next thing we want to talk about are scatter plots. Here's a scatter plot. It's taking several pieces of data. For instance, in 1990, there were almost 45,000 travelers. In 1995, there were more than 50,000 travelers. In 1998, there were just over 55,000 travelers, and it put all this data on this chart. Now, this is not linear, but in general, does this have a positive correlation, a negative correlation, or no correlation? In general, if I drew a line of best fit right through those points, it would look like this, which is a positive correlation. This line would basically be going up left to right. So let's look at the difference. So this has a positive correlation, and my answer is as years increases, the amount of travelers increase. And that makes sense. There's more people, more airplanes, more reasons to go somewhere. So as years increase, travelers increase. That is a positive correlation. Here's another example of a positive correlation. As the X value increases in quadrant 1, the Y value increases in quadrant 1. Positive correlation. Here's a negative correlation. As the X value decreases, the Y value decreases. And that said that wrong. That's why I hesitated. As the X value increases, the Y value decreases. That is not right. As the X value increases, the Y value decreases. So this is a negative sloped line of best fit that goes through that data. So that is a negative correlation. And one like this would have no correlation at all. It doesn't go up or down. It's just kind of all over the place. So let's look at several examples of this. Here's a scatter plot dealing with wages. The x-axis is labeled as hours worked, and the y-axis is labeled as wages earned in dollars. It asks, does it have a positive or negative or no correlation? Well, I can look at the data and realize this has a positive correlation. As hours worked increases, wages earned increases. And that makes sense. The more hours you work, the more money you make. Makes perfect sense. So really, without even seeing the graph, we might have gotten the right answer. Do you think, if they have asked, do you think hours worked and money earned has a positive or negative correlation? Well, it has a positive correlation. The more you work, the more you're going to make. So if we had to say or explain the positive correlation, that's basically what we would say. The more hours you work, the more money you make. Positive correlation on this one. Here's another one. This scatter plot goes up left to right when you draw the line of best fit through it. So we would say it has a positive correlation. If we had to explain it, we would say as years go on, the vertical drop in roller coasters increases. They labeled the quadrant 1 graph, vertical drops roller coasters. X-axis is years since 1998. So for instance, 2 years past would be 1990, 4 years past would be 1992, and so on. And then the y-axis is the vertical drop. So as time goes on, these roller coasters are having higher and higher vertical drops, which makes sense. Technology allows them to do stuff like that. Here's another positive correlation. To explain it, we would say, as years go on, the amount of travelers increase. And again, that makes perfect sense. Here's an example where they gave us a table. In year 1650, there were 500 million people. 1850, there were 1 billion people, and so on. They plotted all these points on the graph. They drew a line of best fit. I don't think it's the best drawn line. I think it should go more like this, right through the center of the data. But either way, my coordinates are here, 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 and here. And in general, that is increasing. As years go on, world population is increasing, which makes perfect sense. Also, let me briefly talk about dependent and independent variable. The x-axis is your independent variable. It's independent. Time is going to go on no matter what happens. Your y-axis is your dependent variable. What happens on the y-axis depends on what happens on the x-axis. So for instance, what the world population is depends on what year it is. Time is independent. It's going to roll on no matter what, but population is dependent on time. Population is going to increase as time goes on or increases. Okay, you don't have to write anything down, but just think in your head, what's the correlation and how would you explain it? Real brief sentence, just think in your head how you would do that. This is a positive correlation, and I would explain it. The more you practice, the better you are at making free throws. Because this graph shows us that the more minutes practiced per day equals higher free throw percentage made. Positive correlation. Think about your answer to this one and how you would explain it in one quick sentence. This graph shows us that as the temperature increases, the sales of lemonade increases. It is a positive correlation, positive slope up this line. If I had to explain it, I would say the hotter it gets, the more people drink lemonade, or as temperature increases, sales of lemonade increases. Temperature is independent. The temperature is going to do what it's going to do no matter how many glasses of lemonade are sold. But the y-axis, your dependent variable, is the sales of lemonade. How much lemonade you sell depends on what the temperature is outside. Y-axis is dependent, x-axis is independent. Y depends on X. Sales of lemonade depends on what the temperature is outside. Now think for a minute. What is a beverage that we could sell that would be a negative correlation to temperature? You might have said hot chocolate, or you might have said coffee. But the colder it is, the more coffee or hot chocolate would be sold. And as temperature increases, the amount of hot chocolate or coffee sold would decrease, and that would be a negative correlation. Here's one without a graph. I just want you to see one in a table, but this is your x-axis column. This is your y column. As your x column increases, as time goes on, your y column increases. So this would be a positive correlation. Think about your answer to this one and how you would explain it in one quick sentence. Game tickets at the fair. As your tickets are increasing, your prize is increasing. This is a positive correlation. Now, I honestly don't know if this is tickets sold or if this is tickets purchased, but either way, you have a positive correlation. So if it's sold, you could say the more tickets they sell, the more prizes they have to give away. Or if it's tickets purchased, you could say the more tickets someone buys, the more prizes they win in general. Positive correlation. Try number 5. Think in your head what your answer would be. What's the correlation and how would you explain it in a quick sentence? This is a negative correlation. Your data in general goes down like that. The taller a person is, the less three-point percentage they make. And if you know a little bit about basketball, you'll understand why that is. Because if you're really tall, you're not outside practicing three-point shots. You're inside near the basket practicing short shots and dunks and layups. If you're shorter, you don't play under the go as much. You play outside and shoot long shots like three-point shots. So in general, the taller you are, the less your three-point percentage. Someone short by NBA standards, like a Michael Jordan, 6'6", 6'7", they shoot three-pointers. Somebody tall by NBA standards, like Shaquille O'Neal, 7 foot 1 inches tall or something like that, he doesn't shoot three-pointers, he shoots under the go. So negative correlation here, the taller you are, the less your three-point percentage is. And I thought I'd read the book answers. The one before said the more tickets you buy, the more game prizes you'll win. And for number 5, negative correlation, the taller the NBA player, the lower his three-point shooting percentage. Think about number 6. What would your answer be? This is a positive correlation. And if I had to explain it, now, I like making it even shorter. The book answer would probably say something like this. The more years of formal education you get, the higher annual salary you will get. I would shorten it even more and say, the more educated you are, the more money you make. In general, of course, there are exceptions, but in general, more education you get, more money you make. Think about your answer to this one. The answer to this one is there is no correlation between the speed of a vehicle and its miles per gallon. No correlation. Let's do some more. These are quick and somewhat fun for me. Think about your answer for number 1. Number 1 is obviously a positive correlation. And your formal answer could be something like, as time exercised increases, then calories burned increases, which makes sense. And you could shorten it even more and say something like, the more you work out, the more calories you burn. The more you exercise, the more calories you burn. Think about your answer for number 2. The answer to number 2 is there is no correlation. The amount of books you borrow has no correlation to the amount of fines you pay, according to this. Think about your answer to number 3. And I will tell you that when it's talking about weight in pounds, it's talking about the amount of weight that you are lifting. And repetitions is how many times you lift it. But it's not the weight of the person, it's the weight of the weight you're lifting. Think about number 3. Number 3 has a negative correlation. As the X value increases, the Y value decreases. The more weight you're lifting, the less amount of times you can lift it. How many times you can lift it depends on how much weight you have to lift. If you're only lifting 20 pounds, you may can lift it 11 to 14 times. If you're lifting 120 pounds, you may only can lift it between 1 and 2 times. Negative correlation. The amount of repetitions depends on how much weight you're trying to lift. Think about number 4. Number 4 is a positive correlation. As time goes on, car dealerships are making more money. Reason for that could be population increases, so more people's buying vehicles, or as time goes on, inflation increases, which makes the cost of cars go up, and so the amount of revenue a car dealership gets goes up, but it's probably a combination of both of those. Think about this one. This is a positive correlation. As time goes on, the average ticket price to a baseball game increases, pretty much with inflation. And we can also make predictions about this graph. We could predict in 07, probably going to be about $24. In 08, probably going to be about $26, and so on, based on this. And again, the year is your independent variable. The price is your dependent. The price depends on what year it is. Last one of these. Think about this one. This one has no correlation. The average annual rainfall and the average temperature are not correlated. It may rain just as much in a hot place as it does a cold place, according to this. No correlation. We're not going to graph equations in this video, and we're not going to interpret graphs in this video, but we want to go ahead and start looking at slope-intercept form so that in our next video, we can start graphing. Slope-intercept form is y equals mx plus b. The m is your slope, and the b is your y-intercept. Very important that you know this formula forwards and backwards. Y equals mx plus b, slope-intercept form. It's called slope-intercept form because you need two things to write it. You need the slope, which goes before the x, and you need the y-intercept, which goes after the x. So let's look at an example. Here I have an equation written in slope-intercept form. Let me write the formula right above it, which we wouldn't normally do. Y equals mx plus b. So when you look at this formula, you instantly know my slope is 3 and my y-intercept is 7. So once we learn to graph, when we look at this equation, we would graph a line which crosses the y-axis at 7 and has a slope of 3, meaning you would rise 3, run 1, because that's understood to be over 1. Let's look at another one. If the equation was y equals negative 2/3 minus 1, then my slope I would write as negative 2/3, and my y-intercept is negative 1. I'm going to graph these two for you really quick. On this one on the left, and let me fix the screen a little bit. This video is not about graphing, but I want to show you a graph really quick just so you'll have an idea of why we're doing this. If I wanted to graph this equation, y equals 3x plus 7, I need to know two things. The y-intercept, it tells me is 7. So I find my y-intercept is 7. And my slope is 3, which means I rise 1, 2, 3, run 1. Or I can rise negative 1, 2, 3, run negative 1, rise negative 1, 2, 3, run negative 1, and I can draw my line through those dots, and I just graphed that equation. All you really have to do is put your y-intercept, rise 3, run 1, put another dot. But if we were using paper to make our line straight, we would want to put as many as we possibly could. Let's do this one. Y equals negative 2/3 x minus 1. And I failed to put that x earlier. My bad. Got to have an x there. M before the x is your slope, negative 2/3. And B after the x is your y-intercept, negative 1. So my y-intercept is negative 1. And from there, I rise negative 2, run 3. Rise negative 1, 2, run 1, 2, 3. Or I could rise, because that negative sign can go on the top or the bottom, I could rise positive 2, run negative 3, and I'm going to be on the same line. Negative slope, instantly I know that it had a negative sign, negative y-intercept, there's my negative 1 y-intercept, negative 2 over 3, negative 2 over 3, positive 2 over negative 3, because your negative sign can be on the top or the bottom. So we'll talk more about that in the next video, but let's look at some more equations and make sure we can pick out the slope and the y-intercept. Okay, we'll go through these one at a time. Let's look at number 1. Think about what would you put as your slope and what would you put as your y-intercept. Your slope is negative 1/2. That's what comes before the x. Your y-intercept is negative 2. That's what goes after the x. Think about your answer for number 2. Your slope is negative 4. That's what goes before the x. Your y-intercept is positive 1. That's what goes after the x. Think about your answer for number 3. Your slope is 3. That's what goes before the x. Your y-intercept is 0. That's what goes after the x. There's nothing there. I could write plus 0, but that's not simplest form. You would never put plus 0 or minus 0. It's not needed. It's just y equals 3x. Your slope is 3. Your y-intercept is 0, which means this one is going to go through the origin with a positive slope. Think about your answer for number 4. You have to think about what's understood to be before this x. There's an understood 1 there. So my slope is 1, which means I'm going to rise 1, run 1. And my y-intercept is 1. Now, instantly, I know this line is going to go down, negative slope. This line is going to go down steeply, negative slope. This line is going to go up, rise 3, run 1. And this line is going to go up at a perfect 45-degree angle because I'm going to rise 1, run 1. So I instantly know what my line is going to look like by looking at my slope. Negative slopes go down, positive slopes go up, left to right. Here we're going to be given the slope and given the y-intercept, and we have to write an equation in slope-intercept form. So it's always going to be y equals, and think about what's going to go before the x. In this case, the answer is 5 because my slope is 5. And what's going to go after the x? In this case, it's negative 3 because my y-intercept is negative 3. So y equals 5x minus 3 would be that equation. Okay, you try to write an equation for number 2. So y equals mx plus b. You're going to replace m with the slope and replace b with the y-intercept. Just jot that down real quick. That's going to be y equals negative 2 is my slope. It goes before the x. Positive 7 is my y-intercept. It goes after the x. Try number 3. Write it in slope-intercept form. y equals negative 6x minus 2. The slope negative 6 goes before the x. The y-intercept negative 2 goes after the x. Try number 4. On number 4, your answer would be y equals 7x plus 1. Slope positive, y-intercept positive. Try number 5. Number 5 would be y equals 3x plus 2. Try number 7. Number 7 would be y equals x minus 12. While 1x wouldn't technically be wrong, we don't write it because it's understood, and that would not be simplest form. Simplest form of 1x is just x because the 1 is understood. Try number 6. Number 6 is y equals negative 4x minus 9. Ooh, try number 8. Number 8 would just be y equals 8. Because y equals 0x plus 8, 0 times x is nothing. That's not simplest form. Simplest form would just be y equals 8. That is slope-intercept form. Let's try a few more. Try number 1. Number 1, y equals 1/4 x plus 3. We would put a dot at 3 on the y-axis, our y-intercept, and from there we would rise 1, run 4, put our next dot, and draw a line through it. Last two, number 2 and 4. Number 2, your equation would be y equals 3/2x minus 4. On number 4, your equation would be y equals 2.5x plus 3.5. Or you could put negative 2.5 here, positive 3.5 here. Thank you.